Hello, hello. Okay, thank you everybody for your patience. It's always fun dealing with a bunch of different video display import devices. So welcome to the Serious Games Showcase at Unite 13. I'm Davey Jackson. I am the Director of Simulation and Visualization for Unity. So as we saw in the keynote this morning, Unity is taking over the game space. But one of the things that's really compelling about Unity is its incredible flexibility for creating all kinds of interactive digital 3D content. I was talking with a client recently, and he said, you know, the great thing about Unity is that you guys are the new end of the production pipeline. When you think about 3D modeling tools and content creation tools of the past, you know, film was the end of the pipeline. But now in this interactive digital era, Unity is really the last place that, the last tool that you need before you ship off your game. So, you know, I have a fun job at Unity. I get to take this amazing technology stack out to virtual reality vendors and shows, serious games creators, data visualization shows, and say, look, we solved a bunch of problems intelligently, and we have a low-cost model that means that you can take some of these existing models and bring them into an interactive format. So today we're going to show you some of the leading projects that I've found over the course of the past year that showcase Unity in new and innovative non-game ways. So today we have speakers from NOAA, which is the US effectively weather service. They do a whole bunch of stuff which they will tell you about in Unity. We also have a presenter from Bohemia Interactive Simulations. They are one of the largest serious games producers in the world. And they are going to talk about how they're using Unity in their production pipeline. We also have David Sorno from Lighthouse, who's been using Unity for interactive media applications to enhance website and papers investment of their viewers in developing stories. We have Frank McPherson from Janus Research, who's going to show some of the projects that they've been working on with Unity doing virtual soldier training. And we also have a medical project example from Rhett Crocker from Z-Shift. Now, quick show of hands, how many of you have visited the Unity website and seen our Serious Games demo video before? Okay. Just about half. In the interest of time, I'm going to skip over it. For those of you who are interested in seeing a montage, we actually each year put together a demo reel specifically around virtual training. Since a good number of you have seen that already, if you visit unity3d.com/sim, we have the 2012 montage up there. For those of you who would like to be in the next demo video that we're going to put together, please put together a 90-second video of your Unity content, watermarked in the lower left corner. You can include environmental sound effects in that demo video, but please don't have a background audio track or do voiceover. The reason is that we're going to cut it up and we want to be able to brand it and make it feel like a Unity experience. Please give us all Unity content. I did one time post something that wasn't our content and was later corrected. It was a little embarrassing. And then along with that, please send us a short description. I attend between 6 and 9 trade shows a year outside of the entertainment space, and we have this montage playing in the background so that people that are looking for non-game examples can come up and talk with us. So if you have a description of your studio's work there, I can reference them to that, and please include a website link in that. And the selection of the content for our montage really has an emphasis on visual storytelling. So if your app needs narration or a live person, it won't likely be included. We want something that tells the story by itself. I'd also like to please request that in the interest of time and respect for our speakers that we're looking to feature today, that you save your questions until the end of the session. We have a mic in the middle, and then we'll bring the speakers up and have you ask your questions in. So with that, I'd like to introduce Craig Williams of Bohemia Interactive Simulations to come up and talk about how they're using Unity at BISim.
Thank you. Thanks for the intro, Davey. My name is Craig Williams. I'm a project lead with Bohemia Interactive. And today I'd like to talk to you a little bit about how we've been using Unity as a simulation tool And I'm going to back that up with some examples of how you might see at the bottom of the slide there a few products that Bohemia Interactive make. And this talk is sort of, those examples of how we've used Unity to augment and enhance those products. So I'd just like to start with a brief introduction, both for us and Bohemia Interactive, as well as talk about those examples and how we've used Unity before I start to talk about, some of the future stuff that we're looking to use, between Bohemia and Unity. So I don't think I really need to say this to an audience like this, but Unity is gaining a pretty strong foothold in the simulation and serious games markets. But I think it's fair to say that at the moment that usage has really been for sort of market newcomers or new products. Now the question of why established companies should use Unity is a sort of a tricky one. I'm going to leave that to you guys as a homework question. In our case, it was largely about investment, both in terms of dollars and in terms of time to get started. The question of how, though, is really what I want to talk about here today. In our case, how we were going to use Unity was bounded by a few conditions. Particularly, we didn't want to disrupt our existing workflows and processes. They're there and we've iterated on them and they work. We wanted to, as I mentioned, avoid committing a pretty big investment, and we wanted to leverage our existing knowledge, so both in terms of sort of people and the content that we have in our current game. Simulation tool. Why is it not switching slides here? There we go. So this is what I would call sort of the traditional model of how people tend to use Unity. You may have some existing software in a product, and then you use Unity to create a new product. Now the only sort of link between those two is the company that makes them. When I talk about how, though, this is the model that I'm talking about here. So you still have your existing software and product, and you still have Unity in your new product, but the magic happens in that space in the middle where they overlap, where you can create things like tools and extensions that add new cool features that you may not have thought of before. Come on. Why is this not going to the next slide? Sorry. Sorry, guys. Apologies. So, a little bit about our company. Bohemia Interactive comes from the gaming world. Operation Flashpoint was released way back in the day, and it was a little bit ahead of its time. A big open sandbox world, large terrains, multiplayer, mission content editors, and the like. And a few bright sparks thought, well, why can't we use that as a training tool for the military? And the Australian Defence Force funded VBS 1, which was effectively a prototype for VBS 2, released slightly later on. But over time, the games industry has matured in lots of ways. There's been, visual improvements, performance improvements, mechanics changes, and the likes. And so Bohemia Interactive Studio, which is our sister company, have released some games that have contained those improvements. And we've also correspondingly leveraged off that technology to create better military simulators. And so Arma 3 is now in beta for those who are interested in the Arma series, and VBS 3 has actually just been announced as well. So VBS is largely used for training, tactics, combined arms, mission rehearsal, the kind of stuff that can be really difficult to train troops in. That if they don't have much time to do it, so they're going to do it on a PowerPoint if they don't have a tool like VBS. But it's also used for simulation and for development. As I mentioned, the engine is quite flexible. You can create your own functions and the like. So let's talk about some examples of how we've used Unity with VBS 2 to create sort of something more. The first area we looked to was enabling interactions, and that's really how about we could take VBS 2 off of the PC, which is where it's largely based, and onto devices like iPads and the like. And one of the things about VBS 2 is because we simulate such a huge number of vehicles and functions and the like, and this is probably the same with many simulations, screen real estate becomes a real issue. And one of the ways of solving that is through consistency. But obviously, some customers want really high resolution, high fidelity functionality for their vehicles or their particular training need. And so in this case, we developed a concept light armored vehicle gunnery panel, which is basically a panel that has some information about the weapon and the state of the ammunition. And we put that onto an iPad using Unity, and then used that to communicate through the VBS2 API into VBS2 to control the simulation and receive data from it. Now, the nice thing about that was that A, we could put it on a device. That was really cool, and Unity made that so easy. But the really interesting thing about putting it on a device is that it means it's much more like the real vehicle. It's much more like a simulator. And you can, if a customer doesn't want to see that panel, because they may not be interested in that particular kind of training, they never even have to know it exists. The second area where we started to look into using Unity was in rapid concept generation and content reuse. Now, this is maybe a fairly obvious one when you think about using Unity as a tool. What you're seeing on that slide there is on the left-hand side is the top picture is of a Type 45, which is a ship in the UK Navy, a hangar of it, and in the bottom you see sort of that inner, highlighting some of the safety equipment. On the left, it's a little hard to see because it's a bit dark, but what you're seeing is a Merlin helicopter. And both of these were iPad-based sort of safety familiarisers that we did for the UK Ministry of Defence. The nice thing was that they were developed using existing content, so we could just take the Type 45 model we had in VBS2, the Merlin helicopter model we had in VBS2, and we were able to basically drag and drop it into Unity, which is really freaking cool. And then the other surprising bit was that we started to play around with things like control designs and visual mechanics, and because of the way Unity works, we were really easily able to iterate this back with the customer, which otherwise would have been quite difficult in something like VBS2, because it's kind of an established product and can be difficult to change. So the last example I'm going to give here is something we've been looking into recently, and that's in opening doors to new markets. Particularly, we've been looking at the mining and resources industry. And one thing we started looking at was a drift runner mine transport vehicle. Now, at the top, that image, what you're seeing is a training manual for the start and stop procedures for a drift runner mine vehicle. It's not really complicated, I must say, 4 steps to start and stop it. But what is complex is how that dashboard works. There's a lot of gauges and buttons and things that do stuff that complexity is really not captured in the training manual. So we just create a really quick simulation of it, to show the trainee how the vehicle feeds back, what the gauges do, what sounds it makes, how it vibrates and the like. And it allows them to, because Unity is quite flexible, we can embed that sort of stuff into the training manuals for them. Now, this obviously has sort of applications in maintenance training and the like, which we realized pretty quickly. But again, you come back to that idea that this actually augments VBS2. We can then now take these really high fidelity concepts and put them into a really generic simulator like VBS2. So, unfortunately, I don't have heaps of time to talk about all the examples and stuff that we have been doing, but hopefully I've shown you that there are other ways to use Unity more than just as a product. It's important to note that these projects have all come from experimentation. There was no overarching plan on how we were going to do this. And like last year at Unite, I was sitting down where you guys are, trying to work out which end of Unity to point at the customer. And this year I'm presenting, but I can see it being a really useful tool for us, particularly in peripheral development. There's all these cool ways of interfacing or interacting with software these days. Well, Leap and Kinect and the Oculus, who are sponsoring the show. And the nice thing is when they are released, they release things for Unity straight off the bat. So we can now test them, trial them before we actually get to the point of actually developing for our software. So in short, you can expect to see a lot more from Bohemia. There's actually a couple of asset store plugins that I haven't mentioned today. One from our partner with Calatrix, which allows Unity simulations to interact with other simulations in a federate. And the other is from TerraSim, who are a subsidiary who allows Unity to import terrains created in the TerraSim engine. If you want to know more, feel free to ask me after the show or send me an email. As I said, my name's Craig Williams, project lead. Thanks very much for having me.
Hi there. My name is David Sarno. I founded a company recently called Lighthouse, and the Lighthouse is using interactive 3D game technology to tell stories from reality. I'm a journalist, a career journalist. I just got done being a technology reporter, writer at the Los Angeles Times for 7 years. And in that time, I was covering Google and Apple and all the kind of the usual suspects in Silicon Valley. And I was writing a lot about the iPad when it was coming out, and actually before it was coming out. And one of the questions that was floating around during that time was, how is this new device going to help media and journalism move forward? Because as you probably know, the industry is not the healthiest it's ever been. There's papers shutting down, and reporters are getting laid off, and it's hard to make revenue now that we have Craigslist, and you're familiar with the story of why newspapers aren't in good shape. So the question was, how's the iPad going to help us move forward and tell stories in new ways? And I became interested in how we can use I'm saying iPad, but tablet's unique feature, which is touch. This is an element, a sense, a human sense that we haven't really taken advantage of as storytellers and journalists to tell stories. And as I looked into how to do that, it also just became apparent that the mechanics of developing video games and creating 3D graphics was a whole world that journalism hadn't touched either. Creating a game-like experience, not necessarily that you have to go from level to level and win badges and points, but creating a reality like you do for games, except instead of a fantasy world, a space world, or an alien world, you are recreating something from our reality, from history, from the Yosemite fire that's burning right now, from the Fukushima nuclear accident in Japan. You are doing the journalistic work to figure out what the components of the reality are, just like when we write news stories, but instead of writing it in text, we will get artists and game developers to create a world so that people can understand something by being in the world of it. So just to take a step back for a minute, this is one of the, so I think this is the first video game that I ever played on the Atari 2600. And speaking of Nolan Bushnell that David Helgeson mentioned earlier, one of the first video games, right? And the only maybe somewhat obvious point that I want to make with this is that this is not realistic. Superman is made of maybe 20 pixels, and the scenes are, he flies upwards and there's more buildings above, and this is the early days, and they were doing the best they could. But all I'm trying to say is that as video games have evolved, our ability to represent things in what you would call a realistic way has evolved a whole lot, as you all know. There's a million examples of games that are starting to look essentially real. And so the only point I want to make with that is that, I'll load the demo in a minute, we think of computer graphics and game as very, very much tied to game design. And as graphics get better, games get better. But I just want to kind of insert the idea in your head that because the gaming industry has evolved so much and has been able to create such sophisticated gaming worlds, a sort of unintended side effect of that is that we now also have the ability to recreate reality very realistically. We can, tell stories from education, tell stories from the media, from journalism, tell stories from healthcare. There's a whole universe of reality that game technology and graphics and game mechanics is not being applied to as much as it is games. So I'm going to give a quick demo of one way that I tried to do that. Oops. Let's see here. So this is a Unity, actually, so you saw that little piece of code. I did this on the iPad first because I wanted to experiment with the idea of touchable journalism. So I'm going to do this on the browser because the iPad wasn't working so well. But imagine that this is on your iPad. You load up a news app like the LA Times iPad app, and you have a story about fracking. So here's a graphic. You can just tap on it with your finger, and it brings you into a 3D world. This is not a game. It's a recreation of reality. It's a journalistic representation of how fracking works, the process of fracking. So you get a little bit of information about it. And this is the strata of rock that, if you're going to frack, you have to understand what the strata look like. And there at the bottom is the shale rock, and that's where all the oil and gas is if you're going to frack. And so I'm going to show you a little bit about what the process of fracking is through this graphic. First of all, you have to scan the ground to figure out how deep the shale rock is and kind of get a line of sight to it. And then in fracking, unlike in regular drilling, you actually drill down and then sideways, horizontal drilling. Because the well, what you're going to do, as you'll see later, is you are going to crack open all of that shale rock down there by pumping a bunch of water and chemicals into this drilled hole that you're drilling right now. So you want to drill a hole only in the area that you're going to fracture open, and that's why horizontal drilling is a fundamental part of fracking. This is all in Unity, using Unity tools and art, just like games, but it's not a game. So then they retract the drill all the way up, a mile back up to the surface, and they shove these long lengths of steel pipe down into the hole that you just drilled in order to allow the oil and gas to flow back up, and also to protect the underground layers from all the chemicals and water that are going to be pumped down, which you'll see in a second. I'm not going to do this whole thing, but I just want to give you guys a sense of how fracking works. So they cement this steel tubing in place, and then you kind of lower a gun down there and blow holes, little tiny holes in the tube, so that when you pump the water and chemicals down into the bottom of this well, it'll migrate through the tiny holes and start fracturing that shale rock, because that's what fracking is. It's hydraulic fracturing. You're pumping water and chemicals at super high pressure down into right here, and then it goes into these little holes and cracks open the rock more, and that releases the oil and gas. So here's all the fracking equipment. This is going to give you a little bit of a sense of fracking uses a ton of water. So there's going to be a tiny visualization here of how much water is used for one well. And that is 7 Olympic swimming pools worth of water for one well. I'm just going to skip this so we can move forward a little bit. And then this is going to show you the types of chemicals that get mixed with all that water to facilitate the fracking process. So that could be keeping the tubes clean or reducing the friction of the water as it moves into the cracks. There's a lot of different chemicals in there. Some of them are pretty nasty. 2 minutes, okay, thanks. Hydrochloric acid is one of them. Ethylene glycol, that's antifreeze. Another one. So remember, this is all on the iPad, so you'll tap this with your finger, and then that'll activate the fracking process. All those trucks are basically high-pressure pumps, so they're pumping those chemicals in that water down into the hole that you drilled before and fracturing open the rock. So I don't have a lot of time left, but this is the basic idea of what I'm doing, is using a journalistic approach to gather information, and then using a game design approach to conceptualize and present the information in a way that is accurate, but also is hopefully engaging and interesting so that people can enjoy the process of learning about this. And that's the oil and gas that'll flow back up to the top. There's no limit to the number of topics that you could represent this way. Health is a big one, so I'm working on a project right now with the Stanford Hospital that has to do with childbirth and the development of the fetus. And so your human body is a great three-dimensional thing to explore. We're like walking mysteries to ourselves. We never see the inside of our own body. So not only is it interesting, but it could be very valuable as a tool for doctors to use when explaining medical conditions to patients. Because oftentimes those conversations with your doctor are stressful. They're using technical language. You only hear it one time. But if they gave you a tablet with a visualization, an app like this, that allowed you to go through at your own pace and understand spatially and mechanically how these conditions work, you'd be more likely to remember the concepts, maybe to follow your treatment. So that's basically what I've been doing with Lighthouse. And I just started the company recently. I've got a steady stream of projects coming at me. But I am looking for partners. I'm looking for a CTO and game developers that have experience and that sort of understand this vision and are interested in it and want to kind of plow into the unknown because there's not a lot of this kind of stuff going on. So if you are interested, please get in touch with me, david.sarno@gmail.com or dsarno@stanford.edu. And I still own 100% of my company, and I just feel like that's a little too much. I'd like to give some of that away. So please get in touch, and thanks a lot for your time.
Hi, everyone. I'm Frank. Sorry. Hi, everyone. I'm Frank McPherson. I'm a technical director at Janus Research Group. Higher? Okay. We are a primarily government contracting company in the United States that, I think it just got turned up. Is that good? Okay. Government contracting company in the United States. We do a lot of business with different federal agencies and departments. So I'm going to talk a little bit about using Unity for many projects at the same time and using it with really relatively large teams. I know a lot of folks are independent developers or small shops and stuff. So moving right along, I unfortunately don't have any demos with me today. So we have currently about 115 people in our division out of about a 350 person company. We started doing technology development stuff in about 2001 with 2 people, and then grew from there. We started doing training products and things that look a little bit like games around 2004, 2005, and then started using Unity in 2006 on one thing, and I liked it a lot, so we just kept going from there. We have a bunch of people in regular offices, as you know, traditional offices, and we've been experimenting recently in order to meet our staffing needs with having people remote, and it's actually been working out really well in most cases, so it's good. We have 3 core frameworks or engines that are based around Unity. One of them is our virtual environment engine. That's used to make interactive multimedia instruction, and that's basically using guided training concepts to teach people how to do stuff. An example of that would be if you had some small piece of equipment or some huge set of equipment that you needed to you needed to teach somebody how to operate in a certain way. You would, represent this stuff in Unity, attach behaviors to the things so that the people would, the trainees would be sort of walked through how you do this. So, a degenerate case of that would be like you have a cell phone and you teach somebody how to, turn it on and turn it off and how to make a call and stuff like that. And most of the things we do are actually composed of like hundreds and hundreds of components like that. So an individual component would be pretty simple, but the aggregate system that is made up of these things is pretty complicated, and it might have, one system that we might deliver might have 100 hours worth of training in it. So primarily we do non-kinetic training in this. So moving on from sort of teaching people how to operate stuff, we go on to serious games, which are more free play kinds of environments where you're representing more of not a thing-focused environment, but an environment where things play a part. And so It smells more like a game than the guided training does, but the goal is often not to entertain. It's more to teach people how to do something or how to employ a concept. And finally, we also do a lot of modeling and simulation work that is geography aware. So the point of it is not to do GIS work. That's not the primary thing, but it does have to be, you do have to have accurate representation of terrain models and everything in there. So those are our three main products. We use obviously we use software developers with Unity to create and maintain these frameworks and engines. We use those on all of our production projects, and then we also use it to build tools that the content developers then use to go and create the end products that we deliver to our customers. So the output that the content developers would come up with, I mean, you have your you obviously have your artwork, and then you also have a lot of things that tell the different engines how to behave at runtime. So these look a lot like high-level scripting languages or configuration grammars. So why do we do this way? We're in a competitive space as government contractors in the US. I mean, the profit margins can often be really razor thin, and there are a lot of people that want to get in on the business. So we were trying to optimize our process so that we could deliver things more quickly, deliver things that were operated better, and deliver them faster. So the main thing that we discovered when we looked into entering this training development market space was that a lot of people were using software developers to develop their content that they deliver to the customers. Like they would hand code a lot of these things in C++ or whatever. Every time they had a new project, they'd start over and do it again. Maybe over time they'd come up with a library of good ideas that they would reuse. It didn't really seem like a good way to do it. I mean, software developers are really good at writing software, but they're not the right guys to be developing domain-specific content. For example, if I want to teach somebody how to operate the flight controls in a small airplane, a software developer is not the guy you want to be actually developing that material. You would probably rather have a flight system instructor give him the tools to be able to do that because they already know that domain. They're going to come up with better material. So our approach puts content development in the hands of the people that are good at it. So in effect, we have a team of folks at Janus that develop these core products, and then the customers of that team are the content developers that then create the stuff we give to the customers. Now, the caveat here would be that sometime we do need to put production-oriented software developers on a project. For example, in a serious game project, you might have some sort of interactive environment, and you might have to have somebody program a bunch of behaviors in it or something like that. In that case, we would have software developers that work on that. So the idea is, again, just leveraging core frameworks so that we can efficiently deliver on all these projects. So we have, on 3 core projects that we do, we have 20 plus active production projects this year. And so, you end up with these couple core guys, maybe 12 folks, I think it is right now, developing these engines that then you have, artists and training developers and instructional system designers and subject matter experts. All these guys are using those tools to make the actual material that's delivered to the customers. Kind of, now that I think about it, it's kind of like a pyramid in a way. And I have a little bar chart here. All the roles in yellow are basically folks that are developing content. The purple are folks that are either figuring out what we're going to do next or doing the core tech, and then management is a little bit of overhead. So the way that we do this technically is Unity 3D is obviously a big part of it because we basically don't have to worry at all about the presentation part of the game engine. It's just all there for you. We've been, I mentioned earlier we used it the first time in 2006 on a laboratory safety trainer for the National Institutes of Health. And we liked it so much that we decided to use it for the rest of our stuff a couple years later. And I believe, I believe I'm not wrong in saying that a Janus person has been at every annual Unite conference since the first one. So. Now, the way we keep track of all this stuff, we build the core tech, and then we put all this in a continuous integration system so that all of the dependent projects that are actually delivered to the customers are then built every time we make updates to the core engines and frameworks. And so we have one master Jenkins instance that keeps track of all this, and then a bunch of build servers, typically one per product or a couple per product group, because you don't really, they're not busy a lot of the time, so that tends to be enough. We do distributed version control so that we have multiple branches going of our core technology. So once we put a production project on a certain version of this, we don't force them to move unless they have to. So we sort of do, I don't know if any of you are familiar with version control distributed style, but Git flow sort of plus. So we have these multiple release branches going at a time, and then when we finally reach end of life on a product, we can then, when the last one on a certain core tech branch is done, we mothball that thing and move on to the next one. Externalized domain-specific content and creation tools is also a big part of how we get it done. And then we also use just enterprise issue tracking and wiki tools so that we keep track of everything that needs to be done and store our institutional knowledge. We actually organize our projects in our issue tracker the same way that we would in a continuous integration system. So you have sort of dependent issues. So if a shipping product, you find a problem with it or something, you put in an issue about that, then you identify maybe that was related to this core tech, then you create an issue in there. So everybody, we basically use that to organize the work. So sorry about the not having demos to show and everything. If you guys would like to talk more about how to how to organize Unity in a pipeline to serve multiple large projects like this, I'd be happy to talk more about it afterwards. Thanks.
Hi, all. I'm Rhett Crocker, and I'm going to talk about healthcare simulation that we've been working on for a couple years now. Real quick, though, who am I? I'm an ex-game developer. I sort of do startups. That's kind of my thing. For the past, 20 years that I've been working in this business, I've released well over 100 games, and that's all types of games. I'm kind of a Scrabble nerd, so I've done like 3 of those, I guess, for multiple consoles and platforms and stuff. Did early advert game stuff. Then eventually I switched over to simulation with a company called 3D Solve, and we got acquired, 5 years ago now, by Lockheed Martin, which I didn't last because I didn't like working there. So I switched back to pure games. Had a couple companies. Actually, Third Track is still around. But recently, 3 years ago, I guess, I started Z-Shift, which is very focused on simulation and also software ecosystems. Okay, so now I'm going to talk about Ice Storm, which is, because defense contractors are involved in it, is of course an anagram, or acronym rather. I always forget exactly what it is, but it's integrated clinical environment, which is a thing in the healthcare space, and then a bunch of random words that are supposed to mean something, simulation, training, whatever. So Ice Storm is kind of a thing. It was a group project. Lockheed Martin actually funded most of it. Z-Shift did design and development work, and we actually used a company, Third Track, that's a pure game company that does contract work to fund their games in order to build it, right? I'm going to do a really, really quick demo. We'll see how well this goes with all the AV problems we've all been having. Let's see. Okay, so while this is loading, this is a straight-up healthcare simulation. It is a hospital. Everything you see in the environment is dynamic and configurable. Every patient you see, every bed you see, every nurse you see, all those things are controllable through external systems. It's also a very, very polished space. There's lots and lots of polygons here. Last time we actually even cared, we looked and it was somewhere in the 1.5 million range when we had everything up and running. Now, that's not all rendered at once, although some of our early crappy versions of this did have it all running at once. All right, so that's good enough. Go back to Keynote, and let's see if we can continue. That didn't crash, yay. All right, so I'm gonna tell you 5 cool things about this project. I do this really fast, so hopefully keep up. Okay, first things first. We built a multi-user overlay because Unity's networking system, while great, gave us tons and tons of problems. We use a pretty standard client-server architecture, right? There's like one server and then there's multiple clients connected to it. But a lot of you might be asking, why the hell would you even bother doing that? Unity's networking system is great. No, it's not. It is good if you want to do really straightforward stuff. But if you want to do things like send arrays, we were sending textures around, video actually, or whole, completely serialized objects, that's tough. Additionally, the first pass we did on this multi-user system that had 8 or so clients connected to it, plus servers and all that, we had really terrible network load. And so we, by utilizing a new system that allowed us to have a single channel between each client and each server, that reduced our network load dramatically. Additionally, anybody who's done any major multi-user stuff knows that network instantiate sucks. And by building an overlay on the existing multi-user system, we were able to get around that by actually having all instantiations occur locally and control it completely. I would heavily advise doing something like this if you have to do really serious multi-user content. As a bonus with the instantiation, you can name stuff along the way. One of the other things that you do, one of the other reasons we did that is because we have a sort of distributed application and asset architecture, which allows us to do dynamic stuff, which I'll talk about in a second. The problem with that is once you start doing multi-user content, you're going to end up with mismatched network views. And by the way, I will just point out that that is one of the most confusing error codes I've ever seen. Okay, number 4, we do dynamic environments, like I mentioned. All those rooms, all those NPCs, all the monitors, you name it, every single aspect of that space is dynamic except for the core systems. It's all based on real hospitals, but if you deal with clients like most of us probably do, then you're going to find out that every single one of them wants this exact thing. So that presents a problem, right? If you try and do dynamic systems inside of Unity, sort of by default, you lose a lot of the functionality, right? You lose the ability to burn in light maps and stuff like that. So how do we deal with that? We actually do very constrained customization. So there's sort of a node system built into our architecture that is actually customizable by clients. And at each particular node location, you can drop things in there. So for instance, you say, oh, I really need to have an NPC stand right here. You go add a node right there, and then you can tell an NPC to appear there. Of course, not surprisingly, you can get under the hood there and actually control like every minute detail if you want, but you shouldn't have to. It's a very expandable system, which actually brings me to number 3. All our assets are external, and I would heavily advise doing so because it really, really allows you to do a lot of things. In our system, you can embed arbitrary prefabs anywhere. So, I mentioned a bed. Those beds have, animations attached. They have all sorts of stuff. And in fact, you can attach scripts to those. Now, of course, there is a little problem there because anybody who's worked with asset bundles knows that asset bundles can't have new code attached. Not entirely true. There are actually ways you can attach arbitrary assemblies, but they really, those things suck. You don't want to do that. All right, so if you're doing dynamic systems and you've got external assets and all that stuff, how are you going to control the environment? Well, that's the next one. we actually have the ability to control the application externally. Anything that is web-oriented can talk to the system, right? So basically that means mostly web servers, right? The Lockheed guys actually built an external system called climate control that would actually reach into the system and say, ooh, I'm going to add a doctor here, I'm going to do this training scenario, what have you. Excuse me. Ultimately, those are just text files, right? It's just text strings going into the system, which, what do you know, that actually brings me to the last one, which is a scripting system. So we built a full scripting system for this. I would also heavily advise people to do that. It's not that hard. Unity really makes that stuff easy. We call that scale, again, defense contractors, right? So we had to give it an acronym. Stands for Simple Command Language, whatever. Ultimately, the way it works, and this is why it's so easy, is Unity has already done the hard part. Send message exists. That means you can send arbitrary code to any game object. So all you really have to do is parse a little bit of a string and say, oh, I want to send this command to this game object. The first thing is the name. The second thing is the command. Everything after that is a parameter. Easy. Now, it does get a little bit harder if you actually want to use reflection, which we really only do a little bit, mostly for setting properties and for self-documentation, because that's one of the key parts of our system. I would also heavily advise for self-documentation of your code. The hardest part of that stuff is ultimately about type conversion, because you're basically going from an untyped, completely untyped system to a very strongly typed system. But I would still advise it. We built a really simplistic routing system that basically said, oh, I want to convert something to scale, or I want to convert something from scale. And that means, oh, well, if this is an array of arbitrary objects that I've serialized, well, I can convert that back and forth easily. Doing so has a lot of unexpected benefits. First off, bugs are super easy to replicate, because you can just say, oh, well, I inputted this scale. Here's a string that I put in a bug database, and boom, you got it. Next is the multi-user overlay I mentioned earlier. Scale is actually what that multi-user system speaks. The server is sending to the client scale commands so that all of them execute it at the same time. It works great. All our environmental changes, I mentioned a dynamic environment. When you actually make changes into that environment, you can save it out in the form of a new scale file. And last but not least, just by using this simple method of making a function public, that is a new function that is callable using your scripting system if you set it up right. That's it. So if anybody has any additional questions, please come find me or shoot me an email. That's it. Thanks.
Well, hey there. I appreciate you guys hanging out to the very end here. My name is Eric Hackathorn. I work for NOAA, the National Oceanic and Atmospheric Administration. It's a government lab in the United States that's dedicated to looking at a lot of different earth sciences, as Davey mentioned. National Weather Service is part of us. We do a lot of climate change stuff. But we've been using Unity, I think, in a fairly unique way for data visualization, and specifically big data visualization. Hopefully, we'll be able to do a quick demo here, and I think we're going to start out with a movie as soon as the computer, which was giving us some trouble in the front here, comes online. And I see we've already started. So our goal here is to have an impact on society, and this is why we've made TerraViz. TerraViz is designed to visualize information from the past, present, and future, and it's designed for a world where everything is in motion. Unity, we have a lot of data, petabytes of data actually, and our ability to produce it is exceeding our capacity to analyze. And this is where TerraViz really comes in. Unity and game engines have a unique access to visualize data, and so let's take a look at some quick eye candy in terms of how things operate. We've enabled progressive disclosure. You can see here that we're zooming in to Vancouver. We do a tiling service on the back end, and as we zoom in, we actually transfer to Google Maps from their API. In addition, we can zoom around town. So you can see here that, again, we're looking at downtown Vancouver. And we've enabled dynamic changes of terrain scale. We can look at a variety of data sources. So we have a lot of data. We can also analyze a lot of data from other sources. So you can see here that we can search by tag. This is getting pulled from the metadata from different data service providers. We can search by source. So we're harvesting from a variety of providers, both within NOAA and outside. And then we can search by periodicity, how frequently data gets updated. And here are the results. So let's take a look at a particular model. This is a global model. You're looking at several gigabytes of information. We can scroll through time, as well as, since it is a 3D model, we can go up to the top of the atmosphere, down to the bottom of the ocean. That's about 50 gigabytes of data. At full resolution, that will actually be producing about 100 terabytes per week. So that's a lot. You can see we can analyze that. We're doing point probing. There was a transect there that was made. Here's some quick just annotation. We're highlighting a little La Nina event. And here you can see some of that same annotation, analysis, transects that are done in various settings. So I've captured a few screenshots from the application. Next up, we can quickly, the time wheel has different scales. So here I'm loading in the amount of snow coverage on the polar region, and then going through seasonally. So you can see the variation. If some of you keep up with this, you'll know that the ice is quickly disappearing in the northern hemisphere. And there we are scaling through a seasonal variation. We've written some volumetric shaders. So here you're actually looking at 3D cloud imagery in a volumetric setting. So this is some of the model results. We can slice and dice this a bit like a brain scan, and then quickly do a transect down through to look at two-dimensional information within a 3D volume. Finally, we have a KML importer. So this is different KML information that's being presented. These happen to be the satellites that NORAD tracks. Another example of a KML data set, these are all the volcanoes in the world, so information that's available in a tool like Google Earth could be imported into Unity. These are real-time clouds matched up with model results, so that's a wind vector field. You can see the circular motion that matches up very nicely there with the real-time clouds from satellites. And I should mention with particles, we're also moving from CPU-based particles to GPU particles. So this is the good work from TC Particles. Some of you may have seen Museum of the Microstar. We're leveraging a lot of the technology from the game components here, but applying it to more of an academic setting. We're experimenting with collaboration. This is running a SmartFox server behind the scene, which is very similar to Photon. You can see my colleague there standing on the other side of a two-way video stream. We've sandwiched data between the two of us. And at this point, we're having a shared experience of data. We can zoom in to particular scenes. Here you're looking at a boat that NOAA uses to collect information. We've meta-tagged that boat with various things, and if you click on it, you can link into other types of assets. Likewise, here's another geolocated scene of downtown New York. In this case, we can flood it, which is kind of fun, but for potential use in city planning. So those are the types of scenes that we've been using. Hardware side, Leap Motion is obviously something that a lot of you are probably familiar with in terms of hands-free control. One that may not be as popular is called Z-Space. It's a three-dimensional holographic display meant for a single user. And then finally, the good old Oculus, which is obviously out there today, is another thing that we've been experimenting with for different types of visualization. So this is under active development. It's a work in progress, but feel free to keep track of us. We're on the web. You can download our application and try it out. And the website here, which should appear in just a second, is esrel.noaa.gov/NEIS, or NOAA's Earth Information System. And with some luck now, I think we're going to transition to a live demo. And I don't know if my colleague is mic'd in the back room, but if he wants to start it up and then walk up front.
Hello, hello.
All
so
right.
We're going to do a quick demo of the tool itself for you. And we're not going to run it live. We've created the ability to run tours. So we support the KML spec. We've expanded their tours to be able to change all kinds of environmental settings and load all kinds of data. So I'm going to kick that off and then walk up to the front. So the first thing you can see here is we're showing off our Earth shader. We wanted this both to be a useful application and to be beautiful. And this is not artistic data, this is actually real data. Those night lights are from NASA, and the clouds around the Earth are actually the most recent satellite pass, last 3 hours. And we're gonna load just a little bit of data up here. We're gonna load some real-time clouds for you. And we're going to animate through that. So we wanted to be able to not only look at the data, but smoothly look at it through time, and we can also look at things through vertical levels. So being able to explore that data, to animate it, is very important to us. And from there, we can load different types of data. We can load different maps. These are from different planets in our solar system. For those of you who think 3D is just too newfangled, we certainly have 2D support. This is that same FIM data set we were showing earlier. This is 50 gigabytes of data that you can scrub through in time and dimension, and of course reproject to whatever coordinate system you happen to like. And we're going to end just going back to that New York simulation. And that's the idea behind these scenes, these geolocated scenes, is to be able to embed other content within this world. So for instance, to be able to do training and simulation within this same framework. And there's New York for you.
And of course, if someone was back at the controls now, you'd be actually able to modify and move that around.
Indeed.
Anyways, I was going to say, that's sort of just a quick tour. The gentleman before mentioned the ability to script things in advance. Likewise, this entire tour was basically a simple text file that could be created by subject matter experts rather than programmers. Our goal is to develop a tool where people can really tell stories about data and get those out for the general public for education outreach. Again, the website is ezeralnoagov.com/NEIS. You're welcome to download, try it out, and if you have any questions, get in contact with us. The information for contacting us is on that website. Thank you.